Today we're going to be basically simplifying rational expressions, and this is going to involve a couple different things. One is finding out where we have what's called excluded values, and excluded values are where the denominator is equal to 0. So we are going to be doing a lot of factoring today, so hopefully your factoring skills are up to par, since we've worked on them a lot this semester. Right? So the first thing we're going to look at, though, in simplifying rational expressions is just determining, okay, where is the function undefined? Now, we didn't do lesson 2, which we would have looked at some graphing of what happens graphically of them, and so we can look at it. And so we're actually going to do that real quick with these just for a second. So take your calculator and put this first expression, 6 over g plus 4, put that in your y equals and graph it. So but just make it x plus 4, of course. But put it in your y equals and graph it. Make sure you hit zoom 6. So we'll put our fraction bar in, and what was it? 6 over x plus 4. There we go. 6 over x plus 4. Oops. All right. So we look at the graph. The graph looks like this. Okay. And how many of you your graph doesn't look like mine? Okay? Did you use a fraction bar? If you didn't use a fraction bar, then it doesn't work right. So you do 6 divided by, in parentheses, x plus 4. All right? So if you're not using the fraction bar, then you got to put the x plus 4 in parentheses. Yes? Oh, it's just dead. All right, we'll go grab another one for right now then. That's good, Mackenzie, because I need to make sure there's fresh batteries in it for tomorrow. All right, so we can see that over here on the left, the graph, it comes from the left, it goes down, then it comes from the top, comes down and over. But there's a definite gap there, right? Well, that gap is called an asymptote. All right, we don't actually see it there because it doesn't show up on the graph, but it's a spot where the graph is going to get closer and closer to, but doesn't actually touch it. So where is that value then? And so if I look at the table, and I'm on fractions, that's good. All right. We go up here, we know it's in the negatives, and we can see here at -4, it says there's an error there. All right. Well, why is there an error at -4? Michael?
Because the graph don't cover -4 in the lines.
Okay, that's true. Okay, but there's another reason. Okay. Denominator can't equal 0. All right, because when x equals -4 or g equals -4, if we put -4 in here, we get 0, and we know that we cannot divide by 0. So in this case, the excluded value is that we're going to say the excluded value is -4. All right, so that's how we're going to write it. Okay, excluded value is. All right, because that's where the denominator is equal to 0. How would I know that? Besides graphing it, I can take that denominator, set it equal to 0, and solve. Okay? Take the denominator, set it equal to 0, and solve. And all we care about when we're talking about excluded values is just the denominator. We don't care about the numerator right now, okay, for excluded values. All right, so letter B. We could put this in our calculator also, find it. We're not going to. We're going to focus on just solving this equation when the denominator equals 0. Terry. All right. So we've got a quadratic equation here. All right. And all the ones we're working on today can be factored for the most part. All right. If they can't, it's for a specific reason. We're not going to be using the quadratic formula or completing the square. We're looking totally at factoring. So remember, the first thing we always do factoring is look for the thing they have in common. What do these have in common? X. So we take out the x. We get x minus 15 equals 0. So that means then that either x is 0 or x minus 15 is 0. Hopefully this is coming back to you. Okay. So we're going to say the excluded values are what in this case then? 0 and what else? Positive 15. Okay, so excluded values are 0 and 15. Okay, because both of those will make the denominator equal to 0. All right. Letter C. So we'll set that denominator equal to 0 again. Y squared plus 5y plus 4 equals 0. So we have to factor it. Is there a greatest common factor? All right. They don't all have a y, so then there isn't. All right. So we got to factor this trinomial. All right. So we're looking to see what are the factors of 4 that add up to 5, right? What are they? Okay, 4 and 1. Y plus 4 and y plus 1. Okay. And so when we're doing these, what are the excluded values always going to be then? Or what makes that equal to 0? Okay, what are we looking for, Michael?
We get -4 and -1.
Right, and why is it -4 and -1?
Because it would be opposite.
Right, they're the opposites, exactly. That's what we're looking for. So the excluded values here are -1 and -4. All right, so once we have them in factored form, then we're looking for the opposites. All right. So now we're going to actually simplify expressions. And when we simplify the expressions, we're also going to refer to what the excluded values are. And what we're going to do is we're going to say that it's where the letter or the variable cannot equal those numbers then. So with simplifying, we're going to factor first and then cancel like factors. All right, if there are any that we can cancel. So here we have, and this says solve, and it should say simplify. Simplify each rational expression, and if it's possible, and then we're going to identify excluded values. Right? So here we have 2r to the 4th over 14r. So this, we just have a monomial over a monomial. Right? So then we're just going to simplify them, that fraction. So there's 2 going to 14. Okay, 7 times. So we change the numerator to a 1 and the denominator to a 7. All right? And r to the 4th over r, how many r's can we cancel? Okay, 1r. So this r cancels and we make that a 3. So we get r cubed over 7. So are there any excluded values then in this situation? Because there's no r in the denominator now, is there? Okay. Right. But the thing is, though, it's not about where I end up. It's about where I came from. Okay? Were there any r's in the denominator to start with? Okay, yes, there were. Okay? And so what value can r not be? So here's my original again. 2r to the 4th over 14r. Right? What number can this r not be? 14 times what is 0? 0. So we're going to say that r cannot equal 0. That's our excluded value then. So it simplifies to r cubed over 7, and then r cannot be equal to 0, otherwise it's undefined then. Okay. So we simplify the expression, and then we go back to, we're actually going to look at, when we can factor, we'll look at the factored form to determine when it can or cannot be equal to 0. All right, so where those numbers are at. Okay, so let's look at B. Now we're going to factor everything. Okay, numerator, if possible, the denominator, if possible. Okay. So here in the numerator we have 6n squared plus 3n. Do they have anything in common? Okay, what do they have in common? Okay, a 3 and n. So we've got 3n. We factor that out. And we're left with 2n plus 1, right? With 3n times 2n is 6n squared. And 3n times 1 is 3n. All right, put our denominator back. Now, even though there's not a parenthesis around what's in the denominator, this is all one piece, right? What's down here? Okay. Do they have common factors in the numerator and denominator now? Okay, they do. All right. You can only cancel when they have common factors. All right. I can't do any canceling in the beginning here because there's no common factors because of the plus and plus signs. Okay. It has to look exactly the same. Since these two things look exactly the same here, I can cancel them out. So my answer to this question is just going to be 3n when it's simplified, because the 2n's, the 2n plus 1 and 2n plus 1, because they are common factors, I can cancel them. But now then I need to look at the excluded value. So I need to take that denominator and find out where it equals 0, because that's an excluded value that we can't let that be true. Okay? So when does 2n plus 1 equal 0? So we subtract 1, right? And then do what? Divide by 2. So subtract 1, divide by 2. All right, so then n cannot equal negative 1/2. So we start out, we factor numerator and the denominator. Look to see what common factors they have. Cross them out. Okay. Then when we're done, we look at the denominator and see, okay, where would the denominator equal to 0? In this case, it's at negative 1/2. So say that n cannot equal negative 1/2. That's our excluded value. Okay. All right. Got one more here. (12p over 3p minus 2). All right, so you go ahead and do that one for me. When I look at the table and I put my answer in, then these two tables should be the same, right? Okay. Because if I simplify it, then they should give me the exact same thing here. And if they're not the same thing, what does that tell you? Okay, it's not right. Okay, we made a mistake. Somewhere we made a mistake. Okay, now here's why we use this example. Okay, this example is on purpose. All right, it cannot be simplified. All right, it's in its simplest form right now. Okay, because here's the thing. All right, and I know why Kayla did what she did. Okay, she's got 12p, 3p. Hey, that's 4. Perfect. All right. Maybe you said it was 4 over negative 2 and got negative 2. I understand that also. The thing is that there has to be common factors to be able to do that. So you've got to have some parentheses to be able to do it because you've got to have the exact same thing to be able to cancel. And this cannot be simplified, but we know that p cannot equal what? Michael?
It cannot equal negative 2.
No, good try. Remember, we got to take the denominator, set it equal to 0, and solve. All right, so we add 2 and divide by 3. So it's p cannot equal 2/3. So we must have common factors to be able to simplify it. Because there's a minus sign in the denominator here, I must have the exact same thing in the numerator and the denominator to be able to cancel. And since I can't do that. Okay? In example B, we had 2n plus 1 in both the numerator and the denominator. So I could cancel them. Right? In letter A, we had a 3 and a 2 and an R we could cancel. Right? But you got to have both to be able to do it. All right? But so what did I just show you? Showed you how you can check it, right? You can use your calculator to check yourself. Make sure you did it right. Put the original in Y1, put your simplified version in Y2, and see if they give you the same answer. And it's best to go to the table, not the graph, because where you can see actual numbers. All right? Okay, simplify each rational expression if possible, and we're gonna recognize excluded values again. So we're going to factor if we can. Can we factor w or x plus 2? Okay. Do they have anything in common? Okay, they don't. All right. There's only 2 terms. So anytime you have a binomial, 2 terms, You can only factor out a greatest common factor anyway, so the numerator, they don't have anything. All right, so the numerator stays the same, x plus 2. All right, the denominator, x squared plus 5x plus 6. All right, what are the factors of 6 that add up to 5? Taylor? 3 and 2. All right, so we got x plus 3 and x plus 2. So do I have the same binomial in the numerator and the denominator? Okay, I do. All right, so I can cross those off. Okay, cancel them. Now there's only one problem here. Okay, what's in the numerator now? And the answer is not nothing. Okay, and the answer is not 0 either. Okay, Mackenzie? It's a 1. Because remember, if something goes into itself, it goes into itself how many times? 1 time. So if I cross these off, that means I have a 1 here and a 1 there. So this is going to be 1 over x plus 3. And then we need to figure out what are the excluded values. Yep. Okay, so we simplify that. Okay, x plus 2 goes to itself once. All right, so we have a 1 in the numerator and a 1 in the denominator. And so x plus 3 times 1 is x plus 3 in the denominator with a 1 in the numerator. But we also must identify the excluded values. Now, the excluded values then are still where the denominator is equal to 0. And we go back to, and in this case, we're going to go back to the factored form. Okay, so we have here x plus 2 and x plus 3 in the denominator. So they're equal to 0 at negative 2 and negative 3, right? Okay, so then my excluded values then are x cannot be equal to, and I'm going to move that. So x cannot equal negative 2 or negative 3. Either one of them. Okay? Not just the negative 3 in my final answer, but I have to go back to the original. And if I put negative 2 or negative 3 in there for x, I would get 0 in the denominator, and that can't happen. All right? It's illegal. All right? Letter B. W squared minus 4 over W squared minus 8W plus 12. So we have to factor the numerator and the denominator first. The W squared minus 4. 2 terms, one of them squared. All right. Actually, they're both squares, right? Because 4 is a square also. So we have the difference of 2 squares here in the numerator. So that's W plus 2 and W minus 2. The difference of 2 squares. So in the denominator then, here we have a trinomial. Factors of 12 that add up to 8. Okay, 6 and 2. So W minus 6 and W minus 2. So, do I have common factors in the numerator and the denominator? Do I have the same thing in the parentheses? And where I do, then, I can cancel them, cross them out, just like when you're simplifying fractions. So my answer here then is going to be W plus 2 over W minus 6. And I have to say that W cannot equal, right? Where does the denominator equal 0 at? At positive 6 and positive 2. So W cannot equal 2 or 6. All right? You have to go back to the factored form for when you're talking about where the excluded values are. All right, now let's graph this one and check our answer. All right, so go to your y equals. Put the original in y1. Using x's instead of w's, of course. Put the original in y1. All right, so if you don't have a calculator with the fraction bar, then you have to put the numerator and the denominator in parentheses. All right, just to remind you of that. Then I'll put my answer in y2. X plus 2 divided by x minus 6. And I really don't care about the graph in this case because the table is much easier to check them to see if they're right. So I'll go right to the table and look to see if my answers are the same. And we should see an error at positive 2 and an error at positive 6. All right? Now, we only see the error at positive 2 for y1 because in y2, we don't have that factor in the denominator anymore. Okay? But they are everything else is the same. And that's what you're looking at specifically, making sure everything else is the same where we have the numbers. If they are, you did it right. If they're not, then you made a mistake somewhere. All right, we got one more? All right. All right, this is a situation where we have opposites when we're dealing with our factoring. So the one thing we always want is we always want to have the numerator and the denominator so that they will look somewhat alike when we're done. Okay, so when we factor them. If I factor these as they are right now, so let's just leave them like that for a moment, okay, and just watch what I do. Right. So the numerator, when I factor that, they have a 5 in common. So we take out the 5, and we have x minus 2. If we factor the denominator, this is the difference of two squares, but it's 2 minus x and 2 plus x. So the problem we have here is that, well, I've got an x minus 2 in the numerator, but the denominator is 2 minus x. Are they the same? Okay. They're not the same, so what we have to do is we have to factor out the opposite to do this, all right? And so this is what my suggestion to you is doing this, all right? If you see this for one thing, all I know is when I get an answer, it's going to be negative. Okay, the whole thing is going to be negative. All right? But I'm going to set it up differently so that I take that into account. All right, so you go over there. So what I'm going to do is I'm going to rewrite it to start with because I want the variable first, right? Okay. So I'm going to rewrite this as negative x squared plus 4 to begin with. Because I usually like it to be written this way. And it could be the other way. It could be 10 minus 5x. All right? So I'm going to write it this way to start with. But what I'm going to do is when I factor, I'm going to take the negative out of the denominator. So I'm going to rewrite 5x minus 10. And now I'm going to factor the denominator so that I take that negative out. So then I've got x squared minus 4. So now these things look the way they should be, so when I factor them, I can cancel. Okay. So now I can take out the greatest common factor for both of them. Take out my 5, get x minus 2. And I still have this negative in x plus 2 and x minus 2. Right. Just the only difference is I have that negative in the denominator, which makes the whole thing, actually it's making the whole thing negative. So the x minus 2's, I now have those things that are the same, the x minus 2, so I can take them out. And I have 5 over x plus 2, and I'm going to put that negative sign out front. Okay. And then we'll still say that x cannot equal plus or minus 2. Okay. Where the denominator is equal to 0. So it works the same way as the other ones. It's just that if you get your x squared is negative, then we want to pull that out first, take the negative out. Okay. Vice versa. Right. Let's look at letter B. This one actually is easier than that one, just because of it being a linear term that's negative instead of the quadratic term. So in this case, because it says 18 minus 6r, my first step is going to be, so actually when I write this down on my paper, I'm going to write it the other direction. Okay? So I'm going to write it negative 6r plus 18 over my denominator. And so now when I factor the numerator, I'm going to take out negative 6, not just positive 6. So we get negative 6 times r, and make sure, the key to it is then making sure you change that sign because I'm dividing by a negative when I factor it out. For the denominator, what are we always looking for? Common factor, right? Hey, they have a common factor. They got a common factor of 2. So I have to take out the 2 first. I'm going to do that underneath it here. Right. So I don't have to rewrite the whole thing an extra time. Right. So then what are the factors of 21 to add up to 4. Did I miss something somewhere? I didn't. That should be a negative sign. Okay, so plus 4t minus 21. There we go. That's better. All right. So we've got 2 times t plus 7 and t minus 3. There's a slight error in this problem, isn't there? What's the biggest problem? What? What's the biggest problem with this one? 2 different variables, right? Okay, all right. So which variable you want to use, R or T? R? Okay, so I'll go back and change them all to R's. Sorry. There we go. So we've got the R minus 3's that we can cancel. But we also have negative 6 and positive 2. So since they have a 2 in common, then this is going to be negative 3 over R plus 7. And R cannot equal positive 3 or negative 7. So the biggest thing is just factoring